Welcome.
Hello.
Hello, welcome everyone. Thank you for joining. We've got a very full audience today, which is really exciting. So we're going to give everyone just a second to log in. Thank you. Fantastic. And then we'll get started in just 1 minute here. Oh, perfect. Alrighty. There we go. All right. Well, welcome everyone. Thank you so much for joining us today. I am absolutely over the moon with the webinar that we're going to be presenting to you. This is a highly, highly anticipated webinar and a very exciting topic. We are getting into green cleaning methods. And if you're anything like me as a conservator, there's some concerns about all of the toxic chemicals we use, not only in terms of the impact on the environment, but also the impact on ourselves. So it's really exciting for us to be able to explore opportunities to find greener and more biologically responsible ways of doing our jobs and doing them well to the best of professional standards, and also to be able to share that with all of you. So thank you so much for being here today. I am going to go ahead and turn on the captions. So if anyone would like to have captions on, they are being available for you. So please go ahead and select that option. Just a couple of housekeeping items before we begin the exciting part of the webinar. If anyone has any issues with tech or audio, usually the easiest thing to do is exit and then come back in. But if you do have a problem, please let me know in the chat and I will try to help resolve that. Today's webinar is going to be two presentations from our esteemed colleagues, Fracnesca Ramacciotti from Unibo and Edith Joseph from HES in Switzerland. So today's session will be recorded. We will be posting the recording next week on our YouTube channel, as well as sharing the recording across our social media platforms. So please keep an eye out and please share the content with your colleagues and your friends who might not be able to join us today. We are expecting a full house. We have 100-person capacity. So if everyone could just make sure that you are muted if you're not speaking, that would be very helpful. And then, of course, we will have opportunity for discussion at the end of each presentation. So if you'd like to join in for asking a question, please feel free to pop that in the chat, or I will be inviting people to turn on their cameras and join the discussion after each presentation. So once again, if you have any questions, I'm here to help out, but the people we really want to hear from are Fracnesca and Edith. So without further ado, I'm going to hand over to Fracnesca to introduce herself and also to tell us a little bit more about the green applications of cleaning methods for paintings. Fracnesca, thank you for joining us.
Thank you, Caitlin, and good afternoon to everyone. I am Fracnesca Ramacciotti from the University of Bologna. I am a postdoc researcher, and after my PhD, which was I joined the GoGreen project, and since 3 years, almost 4, I am working within this project. So I will share my screen. So today I will give you an overview of what we are developing within GoGreen project. So why cleaning?
Sorry,
Because
Fracnesca, I'm going to interrupt you
yes,
for just a second. Do you want to try sharing just the window because we're seeing the Zoom blackout on our
yes,
screen? So just to
sure.
make sure we can see your entire presentation because that is important.
Mm, like this is it better?
Unfortunately not. I think you have to share just the window if that's possible. Sorry, we had it
Okay.
perfectly during the test.
So
Let's try one more time. Otherwise, we'll just ignore the
maybe
screen.
here just content.
Sure.
Should I? No, you still see the
It's still loading.
the mm, window?
Well, let's go ahead and hopefully it's just not too disruptive.
Maybe it will disappear. No,
Well, it's just on the top, so hopefully it's okay. Sorry, please
I'm
continue.
really sorry.
That's okay, no
No.
worries.
Okay, it's disappearing. No. I will give you an overview on the materials that we are developing for the cleaning of painting. And as you well know, cleaning is one of the most important and delicate procedures as it is irreversible, and the traditional methods that are often applied may have some adverse aspects. For example, uncontrolled release of the solvent, for example, using cotton swabs, may lead to interactions of the solvent with the paint layers and thus posing risk to the future conservation, for example, leading to phenomena of embrittlement, swelling, or redistribution of soluble components. Additionally, we can have mechanical damages due to the use of the swab, also after gels application for the removal of their residues. Additionally, traditional solvents may pose a risk for the health of the operators and also for the environment. That is why we want to develop new greener alternatives that are also non-invasive towards the works of art. So it's here where GoGreen work package 3 from the GoGreen project enters, and this work package focuses on the development of cleaning systems for paintings and metals. And as I said, I will focus on painting. So it is work package 3. It is organized with multiple tasks, starting from the selection of reference materials, the development of green cleaning methods that are inspired by historical recipes, and also the development of new cleaning systems. Last but not least, the project foresee also applications in situ of the best performing technologies on selected case studies. So in task 3.1, we prepared a survey that was distributed to experts of the field, and we have identified the main solvents that are currently employed, and also some benchmarks as delivery systems, so cotton swabs and the non-woven Evolon. In task 3.2 are more mainly involved the University of Amsterdam and the Rijksmuseum. So here I will present an overview of the research carried on by Han Chu and Momoko Okuyama, and they have studied the varnish removal employing essential oils. As you can see, they have tested a broad range of essential oils which have different efficacy in the removal of laropal and dammar for painting substrates. And these essential oils have been delivered to the surface with the use of Evolon, being covered with the Melinex as they are highly volatile. As you can see, tea tree oil and lavender oil are effective in both the removal of dammar and laropal, but they have focused their research more on lavender oil as it poses less risks for the health and is also locally available. So a step forward sustainability. They have evaluated the efficacy of the essential oils by FTIR spectroscopy and also 3D surface topography. And as you can see, the results are highly promising. They have also studied the different main components that compose lavender oil, and they singularly, and they have observed that the main cleaning action is carried on by linalool instead of linalool acetate, which is another component of lavender oil. Recently, this task has received a contribution also from Victoria Ward from the University of Amsterdam, and she is focusing her research on the use of clay poultices as delivery systems because they are very malleable, so they can adapt to three-dimensional surfaces. She is studying also the use of sorrel extract for the removal of dirt from surfaces in comparison as an alternative to saliva. Last, she is also studying the effect of temperature on the cleaning efficacy of solvents. And moving to task 3.3, where I am mainly involved, which consists in the development of new materials, we have two aspects to keep in consideration. First, there is the selection of solvents, so moving the choice towards greener alternatives, so solvents that are not toxic and also environmentally safe. But also, as I said at the beginning, we want to develop materials that have a good retention, so they allow a good control over the solvent release. And that is why we have focused our research on the production of non-woven textiles via a technique which is the electrospinning, which is very versatile and broadly applied in many technological fields. And it allows to produce materials that have sorbent properties, so they can retain the solvent. Here I am showing a short video on how the technology works. So it is a technology that allows here, for example, with a multi-needle, so to prepare large sheets of non-woven textiles. So once you have your solvent and the retentive system, you combine the two. And here also there is a video where you can see how the materials are used. You load your tissue with the solvent selected, with a defined amount of solvents, so to ensure the full saturation of the tissue. You apply it on the surface, and you, as a mechanical action, you only have a gentle pressure to ensure that electrospun material adheres to the surface, and then you set the time that you want to apply it. Once you remove the tissue, as you will see, the area is already clean and you don't need to apply any further action. This is because, as I was saying, thanks to the sorbent properties of these materials, the mats behave not only as absorbents for the solvent, but also as sorbent for the swelled or solubilized varnish, giving a so-called peel-off effect. We have studied the mechanism of action of these materials, and we have observed that if we vary the porosity, so the pore size of these materials, going towards bigger pores, we have a decrease in efficacy, meaning that this led us to hypothesize that the main phenomenon that is contributing to this peel-off effect is the capillary rise. The first materials that we tested was based on polyamide 6,6, which is not a green polymer, and additionally, the production involves the use of a highly toxic solvent. That is why we changed our production towards a more sustainable one, selecting a natural polysaccharide, which is pullulan, which can be spun by solubilizing it in water. So we have reduced the impact of the environmental impact, but also the impact on the operator that produces the materials. And as you can see, the morphological properties are quite close to the ones that we studied initially with the polyamide 6,6. We started testing it also on a painting that was donated to science with varnish originating from the 19th, 20th century. And as you can see, the results are very promising with a solvent which is gamma-valerolactone, which has a lower impact on the health and on the environment. And this environmental impact was studied also via life cycle assessment by some colleagues of the University of Bologna. And we compared the impact of cotton swabs in blue and of our electrospan tissue made of pullulan. And as you can see, the impact is significantly reduced. The environmental impact is significantly reduced. But this technology is very versatile, so we can also functionalize our materials, for example, with photothermal agents. Photothermal means that our materials, upon irradiation, are able to develop an increase of temperature very local. So we kept as polymer pullulan, and as a photothermal material, we selected nanoparticles of melanin, which are extracted from squid ink. So it's green but not vegan. And these materials are very reactive, and the increase of temperature is very quick. You can reach, by just adjusting the intensity of your LED, different temperatures. So it's very versatile, and these type of materials come very in handy when you have to remove highly insoluble materials, for example, reticulated varnishes, which are insoluble in the common in most solvents, and they are usually removed with mechanical action. But here, as you can see, when we use our material under irradiation, reaching a temperature of 60 degrees, the varnish is easily removed. And the area treated is confined within the boundaries of the LED spot. So it's very precise and it's very tunable. What we are focusing now is expanding our research. So within the project, there is also a partner, an Italian company as partner, Haute, with which we are working to upscale our materials, because of course, as of now, we are producing sizes of few centimeter squares, tens of centimeter squares. But in parallel, we are carrying out also the work in the laboratory. So we are trying to develop materials that are as sustainable as pullulan, but that are water resistant, because of course, pullulan cannot be used with water solution. And this, we are exploring this production, both studying blends, but also collaborating with another European project, MOXIE. As the mats can be easily functionalized, we are studying some materials that are able to allow a real-time monitoring of the solvent evaporation, so functionalized with dyes. And also we want to increase the retentive properties of these highly sorbent materials, studying different inorganic additives such as halloysite nanotubes and graphene oxide. The last task, as I told at the beginning, concerns the in situ application of the best performing technologies, and it is already ongoing. So here there are a few pictures of us testing the materials in studio and also in a villa in Pesaro in Italy. But also, as you can see, the in situ tests are broad and the collaboration are many. So thank you very much for your attention.
Amazing. Thank you so much, Francesca. I appreciate your detailed insights into this really exciting research. So we do have a few minutes for questions and answers. If anyone has any questions, please feel free to unmute yourself and join the conversation. Or if you prefer, please feel free to share your questions in the chat. We did have a question right off the bat, which was the paper. I'm sorry, Natalia, it says the paper on the previous slide. I'm not sure exactly which paper you are referring to, but is it possible to share the link?
Yes, I will provide the DOI of the papers in the chat for everyone. Maybe at the end of the Q&A session, if it's okay.
Absolutely perfect. Thank you so much. That's very helpful. So I had a couple of questions. You had mentioned the collaboration with Moxie, which is another project in the Green Cluster from the Horizon Europe funded group working on green conservation technologies. Could you tell us a little bit more about what you're working on with Moxie and how that collaboration is working?
Yeah, I spent 1 week in at the University of Ghent, so it was a very an amazing opportunity to also see the technology that they are developing and testing it, and we are studying a combined application of our materials. So their technology is very efficient for example, soot removal. So we are thinking of a way of combining the results of work package 3 and their technology for the cleaning of artifacts. But also we have uh, observed that their technology can temporarily change the properties of the tissues that we are developing. So we aim at making more hydrophilic tissues that are water resistant. So trying to have all the advantages that has pullulan in terms of sustainability and non-toxicity. But the main disadvantage, as I was saying, is that it is soluble, so it cannot be used on water with water solutions.
Mhm.
But most of the polymers that are, of course, water resistant are hydrophobic. So also there you have difficulties in saturating them with the water solution. So with their technology, we are able to change the properties of the hydrophobic materials, making them hydrophilic. And so we hope that we arrive at a solution that takes into account everything and all the efforts that are being made in the two projects. So it's very
Wow.
exciting.
Yeah, that is exciting, and it just goes to show how much further we can go when we go together. You know, the idea of collaboration and everyone bringing their resources to the table to make something completely new. So that's amazing. Thank you so much for that.
Thank you.
And yeah, and we did have a question, which actually was going to be my next question. So great minds think alike. We wanted to know a little bit more about the accessibility and affordability of these materials. How far in the commercial manufacture process are we for the nanofibers? When can we expect to be able to use it as people who are not involved in the research? Also, would love to know a little bit more about where you get your essential oils from. So, lots of questions here, and tell us everything.
So the materials, the electrospan materials, are available as of now via just a material transfer agreement. So you can get in touch with me and my supervisor, Professor Silvia Prati. And because these materials are covered by a patent, so they are not commercialized. So we are not selling them. There's not a price on them. So you can get them free just with a collaboration. So it's an agreement that states that we are sharing all the results. And so Sati, for the commercial manufacture, Sati is a leader in the production of non-woven textiles. So we are trying to uh, with them to develop the materials that they usually produce for other applications.
Mhm.
Um, that can be suitable also for our application. So it's a work in progress. So I cannot tell how far we are, but I would say we are at a good point. We are getting very exciting results, and the testing in situ is involving also their materials that they are developing. So it's a great opportunity to see what works and what not, but we are still um, working on it. And regarding the essential oils, I'm sorry, but I am not able to answer to this question because it's a research that is being carried on by Han, Jo, and Momoko Kuyama, and I really don't know where they are sourcing the essential oils, but they are based in the Netherlands. So and they are buying locally available essential oils. So that's why they are focusing on lavender oil. So I imagine, but I cannot be sure that they are sourcing from the Netherlands.
Okay, fantastic. Well, if we wanted to find out more information, I think if you'd like Henry to send us an email, then we can forward that to the researchers responsible for the purchasing of the essential oils to talk further about that. So I will drop the contact information for everyone in the chat in just a few minutes. So thank you. And as I'm excited to hear, I really like this idea of the collaboration with a commercial entity that can commercialize these products. Because I think that, you know, this is exactly why I was very curious about that, because it's all of the research that we do as scientists is wonderful and fabulous and interesting, but it can be very frustrating when it's not able to be translated into practical daily conservation. So I think that's wonderful to see that there is a work in progress moving towards commercialization, but I would definitely encourage everyone to get in touch if you want to go ahead and try some of this out already. It's available, so that's really great news. We have one more question for you from Iman, and the question is about the modification of the property of the tissue. So, do you mean that you're modifying the property of the tissue itself to be hydrophobic, or the materials that you use?
No, we are modifying the properties of the tissue post-production. So we produce our material and then we treat it with the technology that is being developed by Moxie, and it changes its properties. So from hydrophobic, it becomes hydrophilic. For we have observed 24 hours, but then further are needed. It's just the beginning of a collaboration, which I imagine would be very fruitful and very interesting.
Very cool. Now, sorry, because I'm curious now, you say the technologies from Moxie, is that the atomic oxygen cleaning?
Yes,
I didn't know that that could modify properties like that. That's really interesting.
yeah.
Yeah, cool. Okay, fabulous. Well, thank you for that. So wonderful. Well, thank you so much for your presentation and for the incredibly exciting research that you are doing. Um, uh, of course, Francesca will be here for the rest of the webinar. So if you have more questions for Francesca, please feel free to post those in the chat. Once again, we will share contact information, so please feel free to get in touch to continue the conversation. But otherwise, I would love to thank Francesca for your
Thank you very
contribution,
much.
for being here today, for all of the exciting and interesting things that you're working on. And we look forward to hearing more. And
Thank you.
thank you. Thank you. So now I would like to add to invite, oh, sorry. There we go. Fantastic. Sorry, we had a slight movement in the chat here. Pin, there we are. We'd like to invite Edith to join us. Hi, Edith. How are you today?
I'm fine, thank you. Hello,
Fantastic. Thank you for
everyone.
being here. Wonderful. So, Edith is joining us today from Switzerland, and she is going to be talking a little bit more in depth about the research that her and her colleagues have been working on, more specifically around the green cleaning of metals. So, Edith, I will hand over to you to properly introduce yourself and tell us all about the exciting work you're doing. Thank you for being here.
Thank you, everyone. Welcome, everyone. Good afternoon. Do you hear me well? I think so. It's okay. Perfect. The screen is also shared, so should
Yep,
be okay.
we can see everything perfectly.
Yeah.
Thank you.
So my name is Edith Joseph. I'm professor here in Switzerland at the University of Applied Science and Art, Western Switzerland, which is based in Neuchâtel. We are we are a school of conservation, which have two main domain department, archaeological object, but also technical object. So these two different direction in the conservation education. Regarding the research, we have several projects, and in particular, we are involved with the GoGreen project in different work package, but mostly for work package 3 cleaning and work package 4 stabilization, that maybe we will have the opportunity to speak about in another webinar. We don't know. We will see what we do. Uh, so let me start. So I don't want to introduce any more GoGreen because hopefully Francesca did a nice job introducing this for everyone. Thank you, Francesca. I just want to let you know what are currently the method we are developing for the metal cleaning. So we are focusing on three different metal substrates, which are copper, iron, and silver. And the idea there is to develop formulation or materials which are in combination between green chemistry, biotechnology, and art conservation. So what we would like is to take the most and the best of the world, and in particular of the nature, and to apply this process, which are naturally occurring in nature or around you in the environment, to apply on metals. So how do we do this? We have several, I just want to make, sorry, a step back a little bit. This is a little bit an overview of pertinent and publication in this field about about cleaning in general, bio-cleaning in particular, using some bio-based gel. And it is in it has been developed all around the world. So you know, so of a project like Green Art, for example, or there was a project in France which is called Gel on Metals. There are different procedures that you can see. I hope you see all my screen. I'm not sure.
Yes, we can
Is
see.
it better now? No, it's okay. Okay. And in work package 3, we are not only using gel, but we are also working with Unibo, of course, with the development of electrospun tissue for metal cleaning in particular. But if we focus on gel, what we are doing and what you know is that these gel formulation are based on three components, which is a polymer plus a solvent and active substances. Why we do this is just because there are many advantages working with gel, such as the ease of application. Also, we can be more selective and control because we can look at the gel during the treatment, remove it, decide where to apply it, and also, most importantly, regardless sustainability, is that we can lower down the amount of reagent which are needed. We use here in our lab different biopolymer, which are all from bio-based. They can be produced by microorganisms such as bacteria, which is the case for all the gum, xanthan gum, gelan gum, polyhydroxybutyrate, or PHB if you prefer a little name. But we use also cognac and ayar. So some of these gel, I know you know the name, so you know their property. And we mixed them with some, biosolvent. Oh, why I did this? Did you see the same? No, maybe not. It's me. Okay. So we have this biopolymer, biosolvent, and then we add our active substances. And for us, active substances are chelating agents, which are produced from nature. And in particular, we are using a molecule which is called desferoxamine, or DFO, if you prefer a short name also here. She's produced by bacteria because in nature they need to capture iron. As for us, iron is a nutriment, so they need iron to live. And what we notice is that this desferoxamine, which belongs to the class of siderophore, has a very strong bending affinity, or he loves iron. And in fact, if you look at the constants of affinity, maybe I need to use a little bit of pointer if I can. Is it this? Yeah, you can see this. So the binding affinity of DFO is 30, while the one of the well-known and well-used EDTA is about 25. So it's much above. And we used also a second chelatin agent. Ah, voilà. My presentation was just freeze. Another one which is called with his nickname, which is EDDS or ethylene diamine disuccinate acid, which is much longer to pronounce and to correctly and to mention. And this EDDS has also a nice affinity for iron. You can see it has about 22, but most importantly, it also has a binding affinity for copper. So what we have developed so far is cleaning formulation with DFO for iron and cleaning formulation with EDDS for copper. Here I show you just an example, a comparative study which have been done by a former PhD student, Luana Cuvillier. In that case, we apply both EDT and EDFO in an agar gel of 3%, the same concentration, 60 millimolar, which is about less than 1%. And what we notice is that the result is comparable to both of them. Here I show you another example of again, DFO, the same concentration, the same gel agar formulation of 3%. And also in this case, we have a remarkable, a very interesting surface cleaning. And you can see how it preserves even the trademark, the watermark in the metal. So it's quite soft and smooth. For EDDS, we have here also comparative study with EDTA, but also DFO, because DFO is capable to capture both iron and copper. Of course, in this case, it's less efficient, is what we observe here in the red rectangular. While if you look at EDDS and EDDS also in this case seems have a more clean effect than EDTA. If you see, each time I have mentioned the publication where you can find this result, that's why I don't want to enter too much in detail. It's just to give you small insight and to allow you to then to go deeper in it. A third component that we have studied recently in the GoGreen project is saponin. Saponin is a molecule which is a kind of surfactant. So it can act as a surfactant, but also as a chelating agent, and is extracted from the soap nuts. So I think maybe some of you can use also at home these soap nuts. So it's a very natural product. And in this case, what we obtain is a mild cleaning effect because the bending affinity is lower, but it's also allow, in that case, a more controlled cleaning. Here's some example with this saponin, which is mixed not in water because otherwise it will dry too fast, but it's mixed with a viscous solvent, which is called dipeptic solvent, and we call it sapoline. So it's a mixture of aqualine, which is the viscous solvent, plus saponin, and this avoid any drying during treatment and allow us to perform the treatment directly on the metal surface where the tarnishing need to be removed. So what you have here is different concentration that go from 5 to 9, and also different timing, 10 minutes, 30 minutes till 3 hours. And you can see how, according to the concentration, but also to the timing, that the cleaning effect is even always more efficient. So it's just a question of where do you want to stop, how far, which sensitivity you have with your material, what is your impression. And this was comparable with the EDDS, and in that case, sapoline performed better than EDDS. The same was done for iron, and it was interesting is why the FO maybe not be homogeneous in that case. It appears that sapoline is much more homogeneous, especially when using a low viscous solvent. So it's with a 9% concentration after 1 hour is what we have the best rust removal. So what we did, if you see the first slide was on a copper and iron coupon, but then we moved to alloys. So copper alloys, we use brass, and for iron alloy, we use steel. And on both of them, we use freshly prepared solution. In comparison with a solution which had been prepared 8 months before. The idea was to see how far this solution, once prepared, can be just stored in a normal environment without control of the condition. And it was the case that in both cases, we obtained the same result. So it is something very interesting because that's meaning the shelf life is quite long for this product. Here is some case studies application with saponin, so these soft nut substances, which is either load on evolon tissue, here, this part, so before treatment, during treatment, and after treatment, and the same with agar, gel full of soft nuts, after 30 seconds, and then once the surface is clear. We are always, with gelatin agent, I want to make a note that we always have final clearance with water and or ethanol because we don't want to have any residue of gelatin agent continued, because this will say that the metal then is beginning to be heating and not anymore only the corrosion. So that's why it's important to have this final step. Finally, I move to our last substrate we are studying, which is silver. Here you have an example of how we can apply EDDS also for cleaning silver tarnishing. This is an example that we have performed in 2 years ago, it seems to me. Yes, September 2024 in Vilnius with some conservation department there. You have also, normally it should work like this silver watch, which is of sterling silver. Sorry, there's something wrong. Okay, this is silver plating. This is sterling silver. And we, in parallel to have these case studies, and EDDS, we finally introduce a last gelatin agent, which is an amino acid. I don't want to tell you too much about it because my colleague told me, no, please, we are going to have the abstract, the article. But yeah, of course, the article will be soon out, so we will know which amino acid it is. But the idea is that whatever we are working on, pure silver or sterling silver, in both cases, we can remove tarnishing. And this is very interesting because it's also addressed the case when you have silver enrichment of a surface and you have pure silver sulfide compound, which are much more difficult to remove than silver copper sulfide. So you see on this image, it's just visually that if you increase the immersion time or increase the concentration, of course, you can control like this, your cleaning process. This is still work ongoing. As I was mentioning to you, there will be an article getting out soon about the mechanisms behind this cleaning with amino acid. But we are also now working with different delivery systems, not only gel, but also electrospun tissue with University of Bologna. And I'm sure you will soon hear from us about this also nice results. I think it's all. I just want to show you the last and very promising result we obtained with this amino acid. This is some silver plate brass which have been treated 1 year ago, no, 2 years, January 2024. So it's 2 years ago, and they are still in the same state. And as you can see, if you use the amino acid, yeah, this one has different pH, or this agarty cream, you obtain the same result. So this result of amino acid is comparable to the commercially available agarty. And also the same for sterling silver, we also have a nice result like smooth and controlled cleaning of tarnishing. I was telling you, not only we are doing immersion, but also now we are trying to work in gel application or tissue application. And here you have just the example of before treatment, during treatment with the cell gel, and after treatment. For the gel, we apply two different methods in the preparation. Either we soak the gel, which is already preformed, if you want, in the amino acid solution, or either we mix the amino acid solution in the gel and then form the gel. So there's two ways of doing it, but both ways have give equivalent comparable results. And with all, I have put you also a last slide with all this article where you can find more information, and I'm free for any question if you are here. Also, Chin is online, so she can also reply to this question. Thank you.
Thank you so much, Edith. I have to say it's so exciting to see how much potential there is in this area of research, and it looks like it's kind of a win-win-win solution. Better for the planet, better for people, and better for the object. You're getting even more promising results. So I'm very, very excited to see this. There are a lot of questions coming in. I even have some questions, shockingly. But we'll first go to the chat. So you did mention, Oge was asking about the publication. So you did mention that there's a publication coming out. And of course, I'd like to let everyone know to please follow along GoGreen, subscribe to our newsletter, check out our social media, follow us there, as we will be publishing that information as soon as it is available. But Edith, do you have a timeline for that? Is that something we should be looking for this fall, or?
Yeah,
No
as soon as
pressure.
possible. Yeah, we have pressure. We know. I have pressure from Chin, I must admit. But we will do as soon as possible. Yeah, we plan for, in any case, to get out for spring, for this spring. So
Fantastic.
just few months to be.
Lots to do. Okay, well, we'll make sure that we're supporting you in that.
Okay.
So there was a question, once again, going back to what we were talking about earlier in terms of accessibility and affordability of materials. And Matthew was asking specifically about deferoxamine and where you're sourcing that, because there have been some challenges to find an affordable source. So I don't know if you can speak to that at all.
Yeah, I can. Well, I must admit, yeah, okay, I will reply yes and no, it's affordable. Because in Switzerland, we are lucky that we have also the pharmaceutical industry behind us, and you can buy deferoxamine in pharmacy, in any drug shop.
Oh.
Saying you are doing research, but not for medicine, because otherwise for medicine is a complete, you need certification, for a physician. But if you say it's for research or for case studies, you're a plain new case, it's Switzerland, the sell it to you, and it's not that expensive. It's of course more expensive than other stuff, but it's okay. And at least we are sure on the purity.
Mhm.
And it is the medicament, the drugs, it's called Desferald, in case you are interested. Maybe I can tap it down.
Yeah, that'd be really helpful.
Des,
Thank you.
oops,
And
Desferald. It's from Novartis.
okay.
I have been in contact with Novartis to try to have directly from the source because it's the pharmaceutical industry selling it. So far, they did not reply. Maybe we have not enough market for them. But
Well, maybe if more of us ask, then
yeah,
we'll
yeah. But
start
I think it's
getting.
worth always asking, and so on. The same is
I agree.
for EDDS, for example. For the moment, it's quite expensive, but a lot of industry get interested because it's much more biodegradable than EDDA. And you know, EDDA you use in cosmetic, in pharmacy, in everything. So
Yeah.
EDDS will be also on that way soon. So they need pressure from people. So that's why.
It's basic economics,
Yeah,
supply and demand. So
exactly.
let's keep asking and pushing for it, and then maybe they'll see that there is a market. So
Exactly.
I love that.
And otherwise, if you cannot, or you are living, for example, I know in France they have some problem to have DFO without going to the physician first, and but okay, I can give you a little bit, and yeah, it's more complicated. But there is also a company in Germany who sell desferoxamine A but it's less cheaper than the other one, which is sold by Sigma Aldrich. So I give you really tip and tricks how to get it the most easily possible. Otherwise, of course, here we have a stock, very large stock, honestly, and we agree that, okay, we can discuss if there is collaboration, we send for people to try also if they want to. So,
Perfect. Okay, so get in touch
mhm.
if you want to test some things out. And Edith, if you don't mind, I would love to ask you to type out the two options that you mentioned from Germany, just to make
Yeah,
sure
I will
that
do
we
it
have
after because I need to find again the name of the company, but I will do it
perfect.
in the
Okay,
chat.
thank you. Appreciate that. Wonderful.
I think it
Um,
won't be close, correct? Huh? I can, yeah, but I can do it afterwards. Yeah.
Yeah, afterwards as
Ah,
well is fine. And once again, so this recording will be posted on our YouTube channel. We'll continue conversations there and, of course, on social media. And we will also put the post of the recording on our website.
mm,
So
mm,
we'll have
mm,
lots of places to share additional resources and information. And we'll put everything follow up in those platforms as well. So there was another question
mm.
about the Pleco pen method. You have to excuse me if I
Yeah,
mispronounce
I
that.
need to
I'm
explain what
just
is
a
Fleco.
stone conservator, so so can you tell us, have you done any comparisons?
So first I explain for everyone just in case. Pleco is a electrochemical pen for metal cleaning, and it's also developed in-house here at the same university
Of
by
course.
my colleague Christian de. So yeah, we we say we
Excellent.
want to compare, and this is also Chin discussed a lot with Christian how we will compare them or not. So we hope to do it in the next month. But it is,
Okay,
yeah, we are in the same research team, so of course we compare stuff.
fantastic. So how can we find out the results from those tests that you're going to be doing soon?
Alors, if they are public, we always have on our website, we publish what we are doing, even if it is a small case studies. So you need to go on ArcHark website, so Article Arc. I can give you also.
Perfect. And we'll make sure to
And
share that on GoGreen
and
as
then
well.
you go to under conservation restoration, and you are all the project ongoing and what we are doing. So
Fantastic. Well, we will make
mm,
sure to share that via GoGreen as
mm,
well.
mm.
So that's wonderful. So keep an eye out for the case studies coming out to compare with the Pleco pen. Fantastic. Thank you. Wonderful. So if there are any other questions, please feel free to pop them in the chat. I did have one question. This is just a curiosity.
Mhm,
Could you, because I'm really interested in the saponine, and I've seen those soap nuts, and apparently you can use them for laundry. But
mhm.
I would love to know a little bit about the preparation of the saponine. How does that, what do you actually do to make it work?
Do you want to reply, Chin, maybe? How you prepare saponin from
Yeah,
supplements?
thank
Yeah,
you. Thank you.
I
Chin,
think
it's
she's.
great to have you here.
Mm, mm.
Hello, everyone. Can you hear me?
Yes, thanks for joining us.
Okay. At the moment for experiment, so we use refined product, which we can purchase from, this arteries, sigma arteries, but you actually can buy soap nuts from any even food, whatever supply, and for very, very low price. For example, you can €2, you can get 1 kilo, and then you cook with this soap nut in the water for a certain time, and then you dilute it, and then you refill it, filter it and make it more clean. So for this kind of product can also working as good as refined products. But for experiments, we would like to have something pure product. That's why we're using, yeah. But for for the soap nut, we call decoction. It's also working very well. And we actually already tested. And we actually plan to do something using purified decoction of soap nuts for making sapolene or sapoline to further reduce the cost, because refined products is quite expensive. But for soap nuts, €2 for 1 kilo, you can really, really lower the price. Yeah, that's just
So that's really interesting because it's so accessible and affordable.
Yeah.
It sounds like
Basically, you can buy any website. In the Google, you just type soap nut, you pop out a lot of website, and with very lot of price. Yeah, very cheap price. Yeah.
fantastic.
Thank you.
Fantastic. Well, thank you for sharing that. That's so interesting. And yeah, I have to say it's really exciting to see such promising results from these experiments. So just a huge thank you for sharing with us today. So we are at time. That was a very quick hour. So a huge thank you. I would love to. I'm going to pin Francesca to join us for the final sign off here. But a huge thank you to everyone who joined us today. We had a fabulous audience. Very much appreciate you guys and your interest in this topic, but also your participation and all of your really insightful and interesting questions. Of course, a huge thank you to Ching, to Edith, and to Francesca, not only for the research that you're doing and the leadership in the field, but for sharing it with us. I think one of the things we're very committed to at GoGreen is to making our research accessible and available and inviting collaboration. So if you'd like to get in touch, emails are in the chat. Please feel free to reach out. We'd love to continue discussions. Obviously, our goals here are to make this kind of the standard practice in the field. We want to go green. So we look forward to continuing conversations and to continue to work together towards that goal. So thank you so much, everyone, for joining. Happy Friday. Have a wonderful weekend. Follow along on socials and along on our website with our newsletter to find out more information. And we'll see you at the next webinar. Thanks, everyone.
Thank you.
Thank you.
Thank you.